Hey there everyone, Ramesh here, back again with another video. In this video, we are going to see how to write JUnit test cases for Spring Data JPA repositories. Well, at the end of this video, you are going to learn how to write JUnit test cases for Spring Data JPA repositories. Well, in this video, we are going to use Spring Boot provided very important annotation, that is at data JPA test annotation. So this annotation is very useful to test Spring Data JPA repositories. All right. And if you can see here, this is a 3-layer architecture, and this is a widely used architecture in Spring based applications. All right, we have a controller layer, service layer, and repository or DAO layer. And we are going to focus on repository or DAO layer in this video. Okay, we are going to basically write JUnit test cases for repository layer or DAO layer. Okay, and this annotation, that is at data JPA test annotation, which provides a flexibility to test repository layer with different technologies. Like we can use Spring Data JPA, we can use JPA with Hibernate, we can use a JDBC, we can use Spring JDBC, anything. All right guys, let's go ahead and let's create a Spring Boot application, and we import Spring Boot application in IntelliJ IDEA, and then we quickly write Spring Data JPA repositories, and we quickly write the JUnit test cases for Spring Data JPA repositories. All right, without further ado, let's get started. All right, go to the browser. In a browser, just type start.spring.io. So this will open Spring Initializer. So we're going to use Spring Initializer to quickly create and bootstrap Spring based applications. All right, so look at here, we have two types of projects, Maven and Gradle. Let's keep Maven as a default selection here, and language we're going to use Java. Spring Boot, let's keep this one 2.5.2. so this is the latest release provided by Spring Boot, and don't choose snapshot because they are not stable, so always keep the default selected one as it is. And we're going to use a group ID, something like net.javaguides. You can use any group ID that you want, and I'm going to provide artifact ID as Spring Boot JPA testing. Okay, and the project name is same as artifact, description, and the package name like net.javaguides.spring boot. Okay, all right, so you can give the details as per your convenience, and go ahead and let's add the dependencies. So we are going to use Spring Data JPA, so let's go ahead and let's type Spring Data JPA here and choose Spring Data JPA, and we are going to use Lombok annotation. So go ahead and just type Lombok here and select Lombok dependency, and we are going to use Spring Boot DevTools dependency, Spring Boot DevTools. Here we go, select this dependency, and apart from that we are going to use H2 database. So to keep it simple and to run our Spring Boot application quickly, I'm going to use H2 database, but you can use any database that you want. Like for example, you can use MySQL database, PostgreSQL database, Oracle, etc. All right, as you know that Spring Data JPA internal uses Hibernate as a JPA provider, so you have to only configure the details in application.properties, but the underlying code remains same. So yeah, so you can use any kind of databases, I mean any relational databases. Just make sure that you will configure database specific details in application.properties. Okay, so to keep it simple, I'm going to use H2 database. All right, let's review the dependencies: Spring Data JPA dependency, Lombok, Spring Boot DevTools, H2 database. Okay, great. So these are the dependencies are enough for our example. So go ahead and click on generate. So this will generate Spring Boot application as a zip file, and it will download on file system. So go ahead and open in a folder. So once we extract the zip file, let's go and let's open the IntelliJ IDEA, and we are going to import this application in IntelliJ IDEA. All right, I have opened IntelliJ IDEA here. I am going to click on open. to open the existing project. So I have downloaded the zip file in a downloads folder, and I'm going to choose the application from downloads folder. Click open, and this will import Spring Boot application in IntelliJ IDEA. Let's wait a couple of seconds because Marvin will download all the dependencies from the internet and it will store in a local repository. Alright, go to the main Spring Boot application class. Okay, so now what we're going to do is we're going to create JPA Entity. Okay, so go ahead and right click on the main package, new, and then choose Java class here. Alright, and just give class name as employee, hit enter, and we're going to quickly create the fields here. Private long ID, so this is going to be our primary key for the table. Private string first name, employee first name, and then private string last name, this is the employee last name. And let's define one more field here, private string email. Perfect. So as we have added Lombok dependency to our project, so we are going to use add data Lombok annotation. So we're not going to create a getter setter methods for these fields. In fact, we are going to use Lombok annotation to reduce this kind of boilerplate code. Okay, and we're going to use or argument constructor as well as no argument constructor. Now what we're going to do is we're going to add JPA annotation to just map our Java class to the table, relational table. So for that we're going to use add entity annotation. So this annotation basically make this Java class as a JPA entity. And let's go and let's use add table annotation to provide a table name for this entity. So we're going to use table name as employees here, and let's go and let's define the primary key. We're going to use add ID annotation to define the primary key, and also we define a primary key generation strategy here. We're going to use identity. Okay, that's it. And let's go and let's use add column annotation to specify column details for these fields. So we have a name attribute, and we can provide a name for the column like something like first underscore name, and you can find other attributes here like unique, null label. Okay, I'm going to use null label equal to false. So this attribute basically make this column as a not null. Okay, so similarly let's go and let's add a column details for last name. Name equal to last underscore name. Okay, let's make it as not null. Okay, and let's go and let's use add column annotation here. Perfect. So if you don't add table annotation, then JPA is not enough to provide a table name as a class name. Okay, and if you don't provide add column annotation, then JPA is not enough to provide a default name for the column. Okay, the default name is same as the name of the field. Okay, for example, let's say if you don't add column annotation, then what will be the column name? The column name should be the field name. Okay, post name. And if you don't add table annotation, then what will be the table name? The table name will be the name of the class. Okay, now I'll just undo here. So this table name and column name makes sense. That's why we'll add the annotations to specify the details for the table. Once our JPA entity is ready, we are going to create Spring Data JPA repository to access the data from the database. Alright, so we basically need a CRUD methods to perform different operation on employee entity, right? For that we are going to use Spring Data JPA repository. We'll go ahead and right click on the main package, new, and then choose Java class here and select interface, and just give interface name as employee repository. So this is a standard naming convention, guys. Okay, so this is the JPA entity, that is employee followed by repository. Okay, great. Now let's go ahead and let's extend this interface from JPA repository. And look at here, JPA repository takes two arguments, type of the entity and type of the ID. Okay, and we are going to pass type here as an employee because we need a CRUD database methods for employee entity, and the type of the primary key, that is long. Okay, so for example, if you go to employee entity, here we have used long type as a ID, right? That's why we have provided long type as a ID here, long type as a second argument. And again here we don't have to add repository annotation because Spring Data JPA internally provides add data JPA repository annotation, so we don't have to add this annotation over here again. Now let's jump into JPA repository interface and let's explore what are the methods it exposes. So if you go inside JPA repository interface, then it provides a lot of methods, guys. Find all, okay, and then find all by ID, save all, save and flush. All right, and apart from that, it internally extends paging and sorting repository, and this repository annotation provides support for sorting and pagination. So look at here, find all method takes sort as argument, hence this method supports sorting, and this method takes pageable as a method argument, hence it supports pagination. And apart from that, paging and sorting repository interface internally extends CRUD repository interface, and this CRUD repository interface provides CRUD methods for given entity. All right, so basically JPA repository indirectly or directly exposes a lot of methods to perform different operations on particular entity with a database. Okay, great. And now what I'm going to do is we're going to write a JUnit test cases for CRUD operations. We write a JUnit test case for save employee, get all employee, okay, and we write a JUnit test for update employee and delete employee. Okay, pretty simple. So in order to write a JUnit test cases, what we're going to do is we're going to jump into test package. Here within a test package we have the base package. Right click on this base package, new, and then choose class here, and we're going to use a naming convention something like this, employee repository tests. Okay, hit enter. So as soon as we create a class, let's add data JPA test annotation. So this annotation only scan add entity and Spring Data JPA repositories. It won't scan the components which are annotated with add controller, add service, add component annotation. Okay, so this annotation only scan JPA entity and Spring Data JPA repositories. All right, and then it will store in Spring application context. Pretty simple. Okay, because this annotation only focus on testing the persistence layer or repository layer. Okay, great. Now what we're going to do is we're going to auto wire our employee repository here, private employee repository, and then employee repository. Okay, and here we want to write the JUnit test for save employee. Okay, and here I'm going to write a method public void, let's say save employee test. You can give any name that you want to the method. I'm going to use save employee test, okay, to keep it simple. And as soon as we create a method here, we need to use add test annotation to make this method as a JUnit test. Okay, perfect. Now we're going to create an employee object here, employee equals to new employee. Okay, so what I'm going to do is I'm going to add a builder annotation. I'm going to add a builder annotation provided by Lombok. So go ahead and here use add builder annotation from Lombok. So this is very useful annotation, guys. I frequently use to create the object. Okay, so go back to our employee repository tests, and here I'm going to use builder pattern to build the object employee, and then call builder here. Alright, and then dot first name, let's say Ramesh. Okay, and then last name, let's say Fadtare, and again we have email, let's say ramesh@gmail.com. Alright, then go ahead and call build method. So this will create object of employee. Now what we're gonna do is we're gonna use employee repository here, and employee repository provides CRUD methods, right? So one of the method, that is save method, to save the entity, and just go ahead and pass employee object to this save method. So save method basically save the employee object to the database. Now we're going to use assert statements. Okay, so just type assert that. So make sure that you choose assert that from assertions. Okay, and then we're gonna pass employee object here, employee, and then call get id. So once employee object saved in a database, then the id will be assigned to employee object, right? And that should be greater than 0. So we're gonna call here is greater than, and then pass 0. Okay, so basically this statement validate whether a employee object contains id which is greater than 0 or not. If this condition fails, then our test should be failed. Okay, all right, we're gonna test this JUnit test. So in order to test, you can go ahead and you can click on this icon here to run the specific test, or if you want to run all the test cases which are present in this class, then you can go ahead and you can click on this icon. Okay, so I'm going to click here and run employee repository tests. Okay, so let's wait a couple of seconds. All right, so look at here, save employee test case is succeeded, and if you see the logs, Spring Boot application was started, and then it has inserted a record in the table, that is employees table. This means that we have successfully written a JUnit test case for save method, okay, to test the save method. Similarly, what we're gonna do is we're gonna write a JUnit test for get employee. Okay, so let me minimize this, and here I'm going to write a method again, public void get employee test, and let's add test annotation for this method to make this method as a JUnit test. And here what we're gonna do is we're gonna use find by id method to find or to retrieve a particular employee from the database. We're gonna use again employee repository, it provides find by id method. Okay, and we pass the id here. For example, whenever we insert our first record in the table, then database will create id for the table, right? And the id should be 1, right? And we're going to pass 1 here, and then we're gonna call get method here, because find by id method returns optional object, right? And optional has a method called get, so we can call a get method to retrieve object from the optional object class. Okay, all right, now once we get an employee, what we're gonna do is we're gonna add assert here, assert that employee dot get id is equal to 1. Okay, so the employee that we retrieve from the database, it has the id 1, right? And that id should be equal to 1. So if this condition is true, then our JUnit test will pass, otherwise it will fail. Okay, all right. Now similarly, what I'm going to do is I'm going to write one more JUnit test to retrieve all the employees. So I'm going to just copy this JUnit test and I will paste it here, and I'm going to change the name of the method get employees, or let's say get list of employees. Okay, and I'm going to remove this, and I'm going to use a list here because we are going to retrieve a list of employees, right? Provide employee as a type here, and employee is equal to employee repository, and then we're going to use find all method here. So find all method basically returns a list of employee. Okay, so go ahead and call find all here. Here we add a assert in order to check its size. Okay, assert that we're going to pass employees and then it has a size method, so size method, and here we're going to call is greater than 0. Okay, if the size of this list is greater than 0, then this condition will true. Okay, great. It's pretty simple, guys. We are just going to test the size of the list. Okay, size of the employees object. If this object size is greater than 0, then this condition will true and this JUnit test case will pass. Now let's go ahead and let's write JUnit test cases for update and delete operation. So I'm going to copy this JUnit test and I'm going to paste here, and let me change the method name here. Let's say update employee. Okay, so in order to update the employee, we need to retrieve existing employee from the database. So this statement basically get a employee from the database, and this employee object we are going to update. Okay, just type here employee dot set email. So we are going to update the email here. Let's say ram@gmail.com. So if you look at the save employee test, the email ID is ramesh@gmail.com, right? And we are going to update this email. Alright, so we basically update email from ramesh@gmail.com to ram@gmail.com. Similarly, you can update employee first name, last name as well. To keep it simple, I'm going to update email field. Okay, now once we'll update the employee object, we're going to again save that employee object to the database, right? For that, we're going to call save method here and just pass employee. Okay, and this save method returns an employee object, right? For that, I'm going to simply get that result in some object, that is employee object here. Let's say employee updated. All right, great. And here I will just add the assert that, and I'm going to pass employee updated here, employee updated. Okay, and we're gonna test the update field, right? So what we're gonna do is we're gonna call get email, and then here we're gonna simply call is equal to ram@gmail.com. So here we have just added a assert statement to make sure that the field, that is email field, is successfully updated or not. Okay, great. All right, you can also add assert statement for other fields like first name, last name, but to keep it simple, I have added a search statement to just make sure that the field is successfully updated in a database or not. Okay, perfect. Now let's go ahead and let's create a JUnit test case for delete employee. Okay, so before that, what we're gonna do is we're gonna create one custom method in employee repository. Okay, go to employee repository, and here we are going to create one custom method here. Let's say optional employee, and let's give method name something like find by email. Okay, and just pass email as a method argument. Okay, and save the file, and let's go back to our test class here, and now we are going to write a JUnit test case for delete operation. So just go ahead and create a method here, public void, and method name is delete employee test. Alright, and let's go and let's add an annotation called add test annotation. Perfect, right? Now we're gonna write a logic to test the delete operation. So in order to test the delete operation, first we need to get a employee object from the database. So just go ahead and just retrieve employee object by ID. So we have find by ID method, right? So just call find by ID method here and just pass the ID, that is 1. Okay, and find by ID method returns optional object, so we can use a get here, get method to retrieve employee object from the optional. So now we got the employee object, right? Now it's time to delete this employee object from the database. For that we are going to call employee repository and its method, that is delete method. So you can see here there are many delete methods, so we need to use these delete methods based on the requirement. So now we have employee object, we need to delete the employee object, so we need to call delete method. If you want to delete a employee by ID, then you need to call this delete by ID. If you want to delete multiple objects or multiple employees, then you can call delete all. So now I'm going to call delete method here, and I'm going to pass the employee object to it. Okay, now this will delete the employee object from the database. Now in order to test this, what we're gonna do is we're gonna call the custom method that we just created. That is, first let's give name to this object, like something like optional employee. Okay, and then employee repository, and just call find by email custom method that we have just created, right? And just pass the email ID something like ram@gmail.com. Okay, so what we're gonna do is we're gonna delete the employee object first, and we try to retrieve the deleted employee. And once we delete the employee from the database, and if we try to retrieve the same employee, then the employee should not be available in database, so hence the object should be null, right? So here I will define the object as a null here. Okay, and here I'm going to just check whether the object is present in optional or not. Okay, is present. If employee object is present in optional, then I'm going to assign that object to employee 1 here. Just call get method to get employee object from the optional. Otherwise I will add assert here, assert that, and just pass employee 1, and we are going to check whether the employee 1 is null or not. Okay, just call is null here. Alright, so what we have done, we have retrieved an employee from the database with ID 1. Alright, and then we try to delete the same employee. Okay, once employee successfully deleted from the database, then we try to retrieve the same employee, because this employee email ID you can see here, ram@gmail.com, right? And here we have deleted employee, so employee object should be null, right? So here we are just checking whether a employee object is present in optional or not. If it is present, then we assign, otherwise we add an assert here saying that the employee 1 should be null here. Okay, so once we delete the employee, then if we try to retrieve the same employee from the database, then the object should be null. That is what we have added assert here, is null. Okay, this statement should be true if this test case this test case pass. Okay, all right, we have completed all the test cases for CRUD methods. Basically, we have tested Spring Data Repository methods, save method, find by ID method, find all method, and delete method. Okay, so instead of calling delete method here, you can also call delete by ID method. For example, just call the employee repository here and then delete by ID. You can pass the ID here, something like 1. Okay, so to keep it simple, we have retrieved our employee object, so we are going to call delete method. Okay, so because delete method requires object as a method argument. Alright, now we have written all the JUnit test cases. Now it's time to run JUnit test cases and let's see how it works. So look at here, 4 tests failed and 1 passed. Alright, so except save employee test, all the JUnit test cases has failed. The reason is that JUnit framework do not maintain the order of execution of test cases. Okay, and our JUnit test cases are depends on each other. Because for example, look at here, in save employee test we have saved the employee into database, and in get employee test we have retrieved the saved employee from the database, right? So that's the reason our JUnit test cases are depends on each other. So we have to maintain the order. Okay, first we need to execute this save employee test, followed by get employee test, followed by get list of employee test, update and delete. Alright, so in JUnit framework do not maintain the order, so we need to maintain the order by using some annotations. So go to class level here and I'm going to use annotation called addTest method order and just pass a method argument as a order annotation class. Okay, and we are going to use @order annotation to provide order for methods. Okay, so this test case should execute first, so that's the reason the order is 1, and followed by here we are going to use order 2 because this JUnit test case should execute at order 2. And similarly, let's add a sequence like order 3, order 4, order 5 or something like that. Order 4 and finally order 5. Okay, now we have added an order. Now let's run our JUnit test cases at once and let's see how it works. And there we go. So look at here, even though we have maintained the order, but few of the JUnit test cases has failed. The reason is that, so look at here the statement rollback. Okay, so each and every JUnit test case run in a separate transaction, and we have to disable the rollback, otherwise each and every JUnit test case will run in its own transaction, and our JUnit test cases are depends on each other, so we have to disable the rollback in order to execute these JUnit test cases in a single transaction. So what I am going to do is I am going to use here at rollback annotation here at rollback, and I'm going to add a value as a false. Okay, I similarly go to update employee test here and I'm going to use a rollback and value as a false. Similarly for delete, I'm going to use rollback annotation and value as false. Perfect. Now let's go and let's run the JUnit test cases and let's see the result now. and there we go. So guys, look at here, test fast 5. All the JUnit test cases as fast. Okay, there is no error or there is no test cases failed. It means that we have written successfully all the JUnit test cases for CRUD operations. Okay, so just remember these important annotation like at order, at rollback. Okay, so these are the very useful annotation. So based on the requirement, you can do the you can write the logic by using these annotations. Well, few more important points here, like add data JPA test annotation. It internally uses in-memory database to run the JUnit test cases. Okay, and if you want to use a real database, then you need to provide some more configuration, like you need to update the application.properties file, and then you need to add few more annotations. All right, so to keep it simple, we have used S2 database, right? And again, this add data JPA test is not only specific to Spring Data JPA repository testing, but you can also test JPA entity manager methods, and you can also test other implementations, like for example JDBC template. Okay, for example, I'm going to autowire here, autowire private JDBC template. So you can use JDBC template here, just autowire JDBC template, and you can use its method. And add data JPA test annotation support executing JDBC template methods. Similarly, you can use autowire here, example autowire data source. Okay, data source, and you can use data source methods. Okay, so add data JPA test absolutely support for this implementation as well. All right, so typically we built persistence layer with different technologies like Spring Data JPA, JPA with Hibernate, JDBC. All right, so add data JPA test will support all these kind of persistence layers. All right guys, I hope you pretty much got an idea how to unit test Spring Data JPA repositories.